Okay, so the last trig ratio that we are going to learn is tangent. So the tangent, TAN, of my reference angle theta, what's the only ratio we haven't used? We've used O and H, we've used A and H. The only combination we haven't used yet is O and A. So that is going to be the ratio between the opposite and the adjacent sides. Okay, so using that same triangle we use for sine and cosine, theta's here, hypotenuse, adjacent, and opposite. This ratio is not going to use the hypotenuse. It will be using the opposite side divided by the adjacent side. Okay, so I'm going to teach you a very important acronym for memorizing what sine, cosine, and tangent represent before we jump into doing some examples. Okay. All right, so this acronym, when you are using the trig ratios, always write this at the top of your paper because it will help you remember what sine, cosine, and tangent represent. So the way that we say this, it kind of sounds like a Native American word, is SOHCAHTOA. Okay, so sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Okay, when I was in high school, my math teacher taught me this really silly phrase: some old hippie caught another hippie tripping on acid. So that's a funny way to help you remember the acronym. Okay, so let's jump in and do an example for SOHCAHTOA. Okay, all right, so it says find the ratio for the sine of theta. So remember, if I look at my acronym, sine is the ratio for opposite over hypotenuse. Okay, it might be a good idea, what we just wrote down in that first set of notes, just to remind yourself the sine of the reference angle is the opposite over the hypotenuse. Okay, so we are going to start by labeling our triangle. We can see the reference angle is down here, so I'm going to put a little tick mark there just to remind me. 13, since we're given numbers in this example, I'll just write O, A, or H over the number. 13 is the hypotenuse, since that's the longest side. 13 is bigger than 8 and 7. And then my opposite side from the reference angle is 7. That's my O. And then 8 is my adjacent side. Okay, so the sine of theta is going to be O, the opposite side, which is 7, over my hypotenuse, which is the length 13. Okay, so this is going to be 7 over 13. Okay, and that's it. We'll eventually be doing more complicated versions of this problem, but for right now, what we are trying to learn is, given this specific trig ratio, what is this fraction going to look like? Okay. If you're lost at this point or you feel like you're a little bit behind, I would go back to the beginning of the video and rewatch the section where we labeled with the 3 letters. Okay. All right, example 2 says find the ratio for cosine of theta, which is adjacent over hypotenuse. So I'm going to write down cosine of theta equals A over H. Okay, so I can see my reference angle is up here. My hypotenuse is 20, that's the longest side. 15 is the side opposite of theta. And then the adjacent side is 12. Remember, again, the adjacent and the hypotenuse form the reference angle. Okay? All right, so I can see that the cosine of that angle, since my adjacent side is 12, will be 12 over 20. And if you have a highlighter handy, it might be helpful just in the diagram, highlight what sides you used. That way, if you make a mistake, it's a little bit easier to figure out where you went wrong. Okay. Okay, so moving on. So it says find the ratio for tangent of theta in example 3. So here's my reference angle. My hypotenuse is 5. my opposite side is 3, my adjacent side is 4. And I know the definition of tangent of a reference angle is the opposite over the adjacent side. Okay? So in my diagram, I can see the opposite side has a length of 3 and the adjacent side has a length of 4. Tangent's never going to use the hypotenuse. So the ratio for that angle is going to be 3/4, 0.75. Okay? For the IXL practice, it asks you to either write it as a decimal or a fraction. So this would be perfectly fine to write 3 divided by 4. Excuse me. All right, so in example 4, it says find all 3 trig ratios for x, okay? So what it's asking me to do is to find cosine of x, tan of x, and sine of x. Okay? In this example, rather than using theta, they use x. Sometimes you'll see that, but it doesn't change the definition for the ratios. Okay? So x is my reference angle. If you'd really like to, you can use a theta instead so you don't get confused, but they represent the same thing. Okay? So my hypotenuse is 18. 10 is the side opposite of x. 6 is adjacent. So what we are going to do is we're going to write down all 3 fractions for the trig ratios. Okay? So don't forget, we write it over here to the side. SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay? So since I wrote down cosine first, we'll start in the middle. So the adjacent side is 6, and the hypotenuse is 18. So that ratio is 6 over 18. Okay? And again, if you're confused, if you feel a little lost, pause, go back to the beginning of the video, get clarification, and then come back to this example with us. Okay? All right, tangent of my reference angle is the definition is opposite over adjacent. So since my opposite side has a length of 10 and my adjacent side is 6, that ratio is 10 over 6. And then last one, sine, uses opposite and hypotenuse. That is going to be 10 over 18. Okay? And again, it's a really good idea. Write down SOHCAHTOA each time you do an example to help you remember what each trig ratio uses. O and H, A and H, O and A. Okay, last example. So this is asking me to do the same thing for angle R. It's asking me to find each of the trig ratios, okay? Here it didn't give me, a theta or an x, so I'm going to have to write that down myself for angle R, which is here. I'm going to use theta just because I think that's the best way to show, but you could use an x, okay? All right, so we are finding the sine, and hey, right here we could put theta or R. I'm just going to use angle R, okay, which represents our theta. You could use theta, it's just up to your preference. Okay, so the sine of R, the cosine of R, and then the tangent of R. We are finding all 3. So in my diagram, since R is my reference angle, 13 is the hypotenuse, 12 side ST is opposite of theta, so that is my O. And then 5, I know that kind of looks like an S, but it's a 5, is the adjacent side. Okay? So sine, remember, SOHCAHTOA. Sine is opposite over hypotenuse, so I'm going to use 12 over 13. Cosine, again, is adjacent over hypotenuse, so that's going to be 5 over 13. And then the last ratio that doesn't use the hypotenuse, tangent, is opposite over adjacent. So in this case, that would be 12 over 5. Okay, so I want you to notice something. Sine and cosine, those ratios, the numerator is always smaller than the denominator because the hypotenuse is always longer than the other side. Okay, so sine and cosine will never have a ratio greater than 1, but that is not true for tangent. This ratio can be greater than 1 because those sides, sometimes the opposite is longer than the adjacent. Okay? All right, so a good thing for you to do at this point would be to answer the essential question in a complete sentence at the bottom of your notes. I'm going to be posting some IXL practice for finding the trig ratios, and we will continue with this next week. Bye, guys.